Hi, myself Mohit, and I am here to present you regarding air pollution. Applying machine learning techniques to reduce air pollution. So here is my topic: predicting air pollution level in a specific city. So here goes the content. In the content section, we have certain columns like public view for the problem, the importance of the project, the goal of the research, method used to predict, result, and finally the conclusion part. So we can go from the first, like public view for problem. Like that most of the cities suffer from the high concentration of the air pollutants at the ground level. So regulating air pollution levels has become one of the most important tasks for the government in developing countries, especially China. Now proceed with the indicator of the air pollutants. Like is the sum of all the solid and liquid particles suspended in the air, many of which are dangerous. This complex mixture contains both organic and inorganic particles such as dust and smoke, which is a very major concern for the people's health when it rises in air. PM 2.5 refers to the small particles in the air that reduce vision and can cause headache when the levels rise. So these are the major indicators of the air pollutants which actually indicates us that we are in the society of we are not in the eco-friendly atmosphere basically. Now come with the importance of the project. The importance of the project is the basically the great impact on human health and ecosystems. How eco-friendly is the atmosphere? Air pollution degrades air quality and can lead to many diseases, most notably asthma. Many people causes severely asthma attacks. So here is the data set for predicting the air pollution. You can see here that the concentration of CO means carbon monoxide, C6H6 that is benzene, NO is nitrogen oxide, or NO2 is a nitrogen dioxide, which is a very harmful. Actually, it is basic nitrogen dioxide is very harmful if its concentration is very high in the air atmosphere. And RH you can know the relative humidity, and AH is the absolute humidity. So you can see according to the date and time the how the concentration of each air pollutants goes on to and fluctuates. Like we have the data from 2004 of 10th means like October data. So we can see that 3rd of October we are getting CO concentration is 2.6, but at the same time like we are getting on 6 o'clock is 2.6, and on 7 o'clock is 2, and then it rises to 2.2, or sometimes it's actually stops. So concentration actually differs. So from here we can have a glimpse of the data set at how the air pollution and air pollutants proceed in the atmosphere. Now, the goal of the research is basically to predict the level of air pollution with a set of data used to make predictions to them, and to obtain the best prediction method using several models and compare them and find the appropriate solution for it. Now, the methods used to predict is multiple linear regression model, feed-forward neural network based on backpropagation theorem, and extremely learning machine. Basically, there are various models through which we can prepare the air pollution model like GBM. I have written the code and implemented in GBM model. We can also implement random forest, which is universal algorithm model. So we can actually compare different models, and here I have listed some of the methods like regression, neural network, and extreme learning machine. Now, firstly, we will go through these models. Like, firstly, we'll proceed with the multiple linear regression models, which are trained on the basis of current measurements. It is used to predict the future concentrations of air pollutants in accordance with the meteorological variables. Disadvantage is clearly the basically it contains the noisy data that strongly affect the performance of the regression-based algorithms, and advantages are the integrating complex nonlinear relationships between the concentration of air pollutants and the corresponding meteorological variables. They are widely used to predict the concentration of the air pollutants. And nextly, its disadvantage its ability to generalize is weak and false in the local micro value, lack of choice of analytical method, and consumes a lot of time. The best method is ELM method, that is extreme learning method, and it has a stronger circulation than conventional statistical methods, and ANN with maximum learning speed. Now result goes on. You can see the concentrations of the air pollutants like NO2, NOx, O3 means ozone, PM 2.5, and SO2 is sulfur dioxide. RMSE is the root mean square criteria. R square is adjusted R square value, which actually justifies how good the model is, and rest all are the methods of deciding the models. So MLR is the multiple linear regression model, and FFANN method is the feed forward neural network method, and ELM is the extreme learning method. So you can now actually see according to the season that how the models are behaving in each of the algorithms. Like in summer season, you can see different types of views on multiple linear regression models and neural network and extremely learning method. Same it goes on monsoon, same goes on post monsoon, winter, and then back to summer, and then and that's the way it goes on. Like and lastly, it comes to winter. So you can actually see the metal. The best method is what which has a height value of R2 and low value of RMSE. So basically, we should have a low value of RMSE to get a best method. So we need to pick the lowest value of the RMSE and the height value and the high value of the R2 to justify the good model. So we can look from the data which model is actually suiting this criteria. So the laws using are mentioned here. MAE I have already mentioned you that MAE is the method. MAE is a method to actually calculate the models. MAE is basically mean absolute error model, here is the formula for that. And same goes for RMSE. RMSE is a root mean square criteria, and the formula is used. And lastly, we'll go from the training period section, and here are the air pollutants, and then all the three models, and you can see which concentration is actually high in which model. It can be segregated from this training period, and from this we can easily pick that ELM is the best performance extreme learning method. And basically, we can also name it as random forest with bootstrapping algorithm. We can see that ELM is the best method because we have a very less number of air pollutant concentration here and compared to other one. So lastly, the in this presentation I propose to predict the presentation concentration of the air pollutants on the basis of different algorithms on in which ALM is the best learning method, best performance based on safety prediction indicators such as like R2, RMSE. R2 is adjusted R square value, and RMSE is the root mean square criteria. The present study revealed that ELM performs slightly better than simple statistical techniques. So thanks a lot. Thank you so much for giving me an opportunity to give some views regarding machine learning techniques to reduce air pollution. If ever I will be a small hand in this and helping hand in this, so I would be consider myself very lucky and fortunate to be to be very gracious to present something on air pollution which can be actually very hazardous in future purpose. So I hope this article and my codes and every models will definitely help you and will actually try to make a difference and create some restrictions for these things. So after predicting the air pollution data, we can have several factors. I've already mentioned in my description page that we can actually control the number of vehicles, or we can close some certain factories, chimneys, and halls. All the sources of the air pollution we can actually restrict them. So these are all the symptoms we can actually through which we can predict the air pollution, and these are all the results which we can actually circulate after getting the cause. Thank you again. Thanks a lot for giving me an opportunity to present your article on the air pollution. Thanks a lot.